There you go. Got it.
There we go. Okay.
Now, if you just go to your slide and above the word science where it says automatic zoom, you should be able to pull that down and then increase the size of this text in the slide.
Yeah, it's showing the complete slide. I could make them bigger if you prefer. I can zoom in. But then they won't show. Well, that's okay. I got control over it, so I can do that.
I'd just like to make a privacy note here. So we will record this. We will edit maybe the start, but if people interrupt the discussion with a question, then Zoom will probably record their identity. So if you, we'd like to record the presentation and then stop the recording when we go to a formal question and answer afterwards.
I might also add, if I could, given the nature of today's getting ramped up to go, if you have an intervention you'd like to make, we've got two conditions. One is if it's for clarification, then please do pose that in the chat and I will appropriate time interrupt the speaker. And if it's a comment and or a general question, we'll save that for the discussion period following the presentation. Thank you.
Gord, I'm wondering, this is a PDF presentation. Do you actually have this in PowerPoint or Keynote or something?
I do have it in Open Office, yeah. So I can put it, we can post it in both formats.
No, I'm just thinking for the show, because you're going to have to scroll and keep adjusting the screen size, I think, if you do it in PDF.
No, it's all on single size pages.
Okay.
Why is, oh, there we go. Just switch. Okay.
This is the example, Gordon. You have to scroll this screen. We can only see the first 2.5 paragraphs.
Yeah, I know, but somebody asked me to make the text bigger. It's one or the other. I can't.
You can scroll though, so can you scroll that so we'll be able to see as you go through the text?
Yeah, I can.
Okay, fine.
I can do that. That's fine.
Okay, it's all yours. Go ahead.
Okay, so over the last 50 years, well, actually specifically in the 1970s, Marshall Plan got proved that Galileo was not working from scratch, that notes which he was thought to have written as his original research notes, that is out of his own head, were actually references to course notes for a course on physics. And he, in fact, he had been hired to teach physics at the University of Pisa, and he wrote down his own notes and replied in response to what he was reading. So he was not working from scratch. He was responding to medieval physicists and many of the problems that he discusses in his book. Well, I'll get to it later. I'll talk in more detail about that later, but many of the problems he discussed came from medieval textbooks. So there's several different sciences that continue straight through from antiquity. Acoustics, for example, they cracked acoustics in antiquity, and they understood it completely. So, or almost completely. I mean, they couldn't figure out the molecular level details of sound transmission, but they did understand a lot about acoustics. They understood quite a bit of math, not everything, but quite a bit. Astronomy, by even the 3rd century BC, they could predict exactly where the planets were going to be at any particular time. So they already knew that the planets weren't gods by then. And medicine is really oddball because it continued right from antiquity. It wasn't in the universities, it was taught, it was private. But it continued from antiquity. Doctors maintained literacy in Latin and Greek, or Greek. And so there is a direct propagation from antiquity right through to the modern era, which is rather unfortunate because, of course, the ancient philosophers believed that bleeding was good for you. But that's how that got into the world of science, medicine. So we have to get our terminology right. What do we call a scientist? There's a lot of, these days in philosophy, there's such a thing as philosophy of science and an attempt to precisely define science. But that is ahistoric. That's not how things really worked in the past. In antiquity, at the beginning, there was no distinction at all between wisdom of the scientific type and wisdom of other type. You can see that, for example, in the book of Leviticus, which is, it's got a mixture of commercial regulations, and I've quoted one there, which is, I think, something about you can't mix blue thread in with your other colored threads, and you shall keep accurate measures of weight and length, right? And then at the same time, in the same section 19, you have public health regulations. Now, those are about shared sacrifices, shared offerings. But the point is, when you're doing a shared offering, you're offering food to people who come and attend the ceremony. So they're public health measures, right? They're like restaurant regulations. And so it's got a lot of very practical stuff. And as we'll see later, it also has some very good medical knowledge in it. There's later sections that diagnose disease and tell priests how to cure various skin diseases. And in fact, in antiquity, what we call scientists were called priests originally. Originally, priests just meant anybody with technical knowledge. And how to placate the gods is technical knowledge. How to carry out a sacrifice is technical knowledge. How to communicate with the gods, how to get them on your side and keep them on your side. That was all considered technical knowledge. And so priests were just another type of person with technical knowledge. Eventually, the philosophers came along and started distinguishing between philosophy. Well, at first they didn't even distinguish between philosophy and priesthood, but eventually they did. And then they started distinguishing between natural philosophy and other types of philosophy. The word natura is a Latin word which means the same as the Greek word physika. In other words, it means physical. It does not mean coming from Mother Nature. It means, it doesn't mean not artificial. It means physical. I mean, solid. So natural philosophy is a philosophy of physical causes, looking for physical causes. The word scientist actually is surprisingly recent. It was first invented by Mary Baker Eddy for Christian Science, or the Church of Christ Scientist. Although science is an older word, it just means knowledge. But Mary Baker Eddy invented the word scientist, and it took a while after that, about 40 years after that. So about 140 years ago, the word people started using the word scientist for natural philosophers. But before that, all scientists were called natural philosophers. Darwin, for example, was called a natural philosopher. He was not called a scientist, okay? So that's rather recent technology, rather recent terminology. Unfortunately, the terminology for science is not absolutely fixed and settled. There's been a lot of controversy in the philosophy of science. There have been a lot of bad results with overly narrow definitions of philosophy of science. Definitions, for example, that would exclude astronomers who are just doing observations, because they're not testing a theory, they're just doing observations. So that's not science? Well, it has to be science. Come on, that's unreasonable. The reason some people don't want to include that as science is that the Babylonian priests observed the skies and recorded very detailed observations and very accurate observations for thousands of years. And they called themselves priests, and they did it as a religious duty. But as we'll see, just because something's done as a religious duty can't possibly disqualify it from being science. That wouldn't make sense at all. Galileo himself was a Dominican friar, right? He worked for the church. So you can't say that just working for a church makes it not science. So because this is an historical lecture, it's a lecture about history, not about current practice of science. I will use a broad definition. I will say any serious attempts to understand and explain how the world works using physical explanations. And if we include that, then it goes back well before history and into prehistory, but we don't have records of all that. But it goes certainly as far back as we can in history. And yes, under this definition, astrology was a science because it rejected the notions that the planets were gods, right? Astrology relies on being able to calculate the position of the planets at any given moment. And it was, in fact, a reaction to the ancient proof that the gods were not, that the planets were not gods, because their movements could be totally predicted, accurately predicted centuries in advance. So yes, under this definition, astrology was a science. It's not a very useful science. It's not well regarded today, but it was a science in its time, right? Okay, so where, the other thing we can ask about is Greek philosophy. Where did Greek philosophy come from? I'm assuming we don't have to argue about what philosophy is. Again, we might not regard today, philosophers wouldn't regard a lot of ancient Greek philosophers as actually philosophers. Socrates, for example, was more of a street fighter in argument, but he wasn't much of a philosopher. Plato was more of a mystic than a philosopher, or at least half and half. So I'm not going to discuss what the argument, I'm not going to discuss what the definition of philosophy should be. I'm just talking about the tradition of philosophy and people whom the Greeks in antiquity called philosophers. Okay. So where did Greek philosophy come from? It came from Asia via the Persian Empire in the 6th century BC. Now, there were geopolitical events happened. The Persian Empire was, of course, based in what's now Iran, but it was the link between Asia and Europe. And for a long time, the Persian Empire had problems on its eastern borders, and was preoccupied with its eastern borders. And while it was preoccupied with its eastern borders, a bunch of Greeks snuck in. Greeks got in everywhere in those days. There were a lot of Greeks around. They were in Italy, they were in southern France, the city of Nice on the French Riviera was originally Nicaea, a Greek city. The city of Marseille was originally Marsilia, a Greek city. Greeks were all over the place. And some of them went to Turkey, what's now the Anatolian Peninsula. And they moved in there around the coastline, just around the coastline, just in the coastal settlements. And the Persians tolerated them for a long time because they were busy on their eastern borders. But in the 6th century BC, around 600 BC, actually, around the year 600, the Persians settled their eastern borders and began to feel secure there. So then they started attending to their western borders, and they kicked out the Greeks. Now, Persia was a land-based empire. It wasn't a sea-based empire. So they didn't care if the Greeks only moved 100 meters offshore to an offshore island. They just wanted them not on the mainland. Use soldiers on the mainland. So there were a lot of refugees because of that. I mean, some Greeks just moved a few hundred meters, but some of them moved all the way to Greece, and some of them moved further to Italy, where there were, in those days, an awful lot of Greeks. It wasn't yet dominated by Latins. That was only during the Roman Empire. Okay, so Greeks, many of these Greeks had been dealing with the Persians. They were, they had business dealing with the Persians. They had Persian friends even. And so they knew all about Persian culture, and Persians told them a lot about the East. So these Greeks were rather sophisticated. And they moved west to Greece and to Italy. And they found when they moved west that the other Greeks were very unknowledgeable. They really didn't know anything about the East. And so the Greeks who moved, some of them set up shop as teachers. And that was the origin of Greek philosophy. So Greek philosophy was heavily influenced by Eastern philosophy. For example, Pythagoras, who was one of the first philosophers, taught reincarnation, not just reincarnation, but transmigration of souls, which was foreign to Greek religion, but he taught it. It clearly came from Hinduism, right? I mean, there's a very strong Hindu influence there. There were also Buddhist influences. In the 6th century, Buddhism was just getting started, but eventually, during the whole of antiquity, Buddhists sent missionaries to the West. And by the 2nd century AD, there was a branch of Christianity called Gnosticism, which clearly had Buddhism in it. In Gnosticism, there are two gods, a good God and a bad God. And the bad God tries to keep us trapped in the cycle of reincarnation. And the good God sent, in this case, Jesus, as what can only be described as a savior. But what's the term in Mahayana Buddhism? I've forgotten what it's called, but someone who stays behind longer than he has to in order to liberate other people. So it's very clear Buddhist influences there. Okay, and I should explain that Greco-Roman paganism and Hinduism are not two separate religions. They're two branches of the same religion. They even share rituals. In fact, the classicists use Hindu rituals to tell us more about paganism, about Greco-Roman paganism. They're simply the East and Western branches of the same religion, okay? And it's fundamental to both that they're animist. That is, they try to explain phenomena by positing that there are spirits behind them. The wind blows, well, there's a wind god that blows it, you know? You put your hand in a stream and the water forms an eddy, right? It swirls in a circle. This was a problem to explain. Why? Because water flows downhill. But if the water in an eddy is flowing in a circle, at least some of the time it's flowing uphill. How can water flow uphill? Well, there's got to be a god behind it, a deity. And of course, it's the goddess, who is the goddess of that stream, right? So they had hundreds of thousands of goddesses, one for every stream, even tiny creeks, and one for every lake and all over the place like that. So they had lots and lots of deities to explain everything. And the trouble with that, of course, is it gets ridiculous. How many deities are there? Come on. In the sky, they saw the planets, they saw the stars moving in regular patterns, just repeating, circling around the Earth as they thought it was, geocentric view. But the planets wandered all over the place relative to the stars. I mean, they rose and set like the stars, but they wandered around among the stars, which indicated to Greco-Roman paganism that the planets were gods because they had free will. Obviously, they were wandering around. Planet, the word literally means wanderer. And they knew they were at least thousands of years old because the Babylonians told them that, right? We've been watching them for thousands of years. So the planets must be gods. They're not people. They're not ordinary animals. They're another order of life, gods, okay? All right, so that's the similarity between Hinduism and Greco-Roman paganism, which made it relatively easy for Hindu thinking to come west into Greece. But the Greeks did something weird with philosophy, with Eastern philosophy. They took on practical questions. Thales is one of the very first Greek philosophers for which we have a record. And people objected to Thales that your philosophy is impractical. It's impractical. So he said, all right, I'm gonna make a fortune using philosophy. All right. So he cornered the market in rental olive presses. In other words, he practiced a bit of neoliberal capitalism And the next olive harvest was abundant, and he made a profit by leasing out these olive presses when they were needed because there was such a bumper crop. So he explained that he used philosophy to tell him that there was going to be a bumper crop, and then he made a great deal of money from it. He also tried to answer the question, what's everything made of? This was a major issue with rational understanding of the universe. There's so many different materials, and every single piece is different from every other single piece. You know, this piece of wood has a grain like this, but that piece of wood has a different type of grain. But that's even from the same tree, but they have different grain in them. And they have different hardness and so on. So how come things are so different, and like, are they all made out of different materials? Is every wood really distinct from every other piece of wood? What's going on? What's the order behind all this? This was a serious issue for the Greeks. I don't know whether that was ever taken seriously in the East. I'm not an expert on ancient philosophy, but I haven't heard of it being considered a problem from what little Hindu philosophy I've read. Might have been considered more of a problem in China, but I don't think there's that much Chinese influence in early Greek philosophy. Anyway, Thales tried to answer that question. People asked him, and he said, okay, everything's a form of water. Why water? Well, he didn't record, we don't know exactly, but it seems reasonable to suppose that it's because water was one of the few things they knew that occurred in all three forms: solid, liquid, and gas, or not really a gas, a cloud of steam droplets. But they didn't distinguish between gases and or between steam and clouds of droplets. That they thought that was all just something that we would call a gas. So that was the only common substance that occurs in all three forms. And you know, they weren't very familiar with ice because the Greeks avoided the tops of mountains and lived down in the valleys. But you know, there was maybe a couple of times a year there was a snowfall in the winter. Or maybe there was a little bit of ice that somebody brought down from the mountaintop. During the Roman era, we know people brought down ice to put in drinks. So ice was known, right? So it's likely that that's why he picked on water. His disciples went on to change that. Let me just check what's on the next slide. Yeah, his pupils are on the next slide. Anaximenes and Anaxagoras are two of his pupils, and they continued this theme. This is called monism, by the way, the philosophical notion that there's really just one single material, and everything's made of that material. Anaximenes argued that the real stuff of the universe is air. Why? Because air is always moving. Now, that was itself a controversy. A lot of people thought if you can't see something, it can't be real. So wind only, or detect it, it can't be real. So if you don't notice it, it's not real. So air only exists when the wind blows. They didn't think air was anything at all. They just thought the wind was what matters. So Anaximenes was apparently working from that basis, that air moves by itself, apparently. So it's the real stuff of the universe. It explains all motion in the universe. It's all air. And he talked about clouds, you know, how steam condenses into clouds, and clouds condense into rain, and rain condenses apparently into rock and trees and stuff like that, according to Thales. Anaxagoras is a bit more interesting philosophically because he said, look, if it's all one substance, why do you want to give it a name like air or water? Maybe it doesn't have any particular form that's specially it, so we should call it formless. And the word for that in ancient Greek is apeiron, right? So that was his contribution. So these were called the monists, right? This form is called monism. It was abandoned later on, as we'll see. In fact, it was only the first philosophers who bothered with monism. Okay, early Greek philosophers, some of them at least acted like Hindu holy men. I mentioned Pythagoras already. He had a cult. It's fair to call it a cult. There was nothing embarrassing about having a cult in those days. In fact, not Hinduism, but Greco-Roman paganism was full of cults. And it just meant a subset, part of the religion devoted to one particular deity or semi-deity. And Pythagoras claimed to be one of those, a semi-deity. His followers had to live regimented lives. They lived in dormitories. There were all kinds of arbitrary rules, how and when to roll up your bedroll, but all kinds of other stuff. But he also set them mathematical tasks. I'll be getting ahead of myself to say what mathematical tasks he set them. But his cult didn't last long after his death. It lasted a little while. Well, no, it lasted for, I guess, for two and a half centuries. So that's not too bad. But anyway, his followers did make important advances in mathematics, which I'll talk about later when I talk about math specifically. Another example of a Greek philosopher who acted like a Hindu holy man was Empedocles of Aggregantum, who was also known as Empedocles of Aggregantum because the city had a Latin and a Greek name. He claimed to have superpowers. He claimed he could still the wind at will, right? He claimed other superpowers too. Empedocles, he kind of did have some superpowers because he made some important contributions to philosophy, to science, even though he seems to have been fairly nutty. For example, he invented the 4 elements: air, earth, fire, and water, which was the answer to the monism of the earlier philosophers. No, there's not just one substance. There are different substances and they interact and they mix with each other. This is the beginning of what was later to become atomism, which is another subject I'll discuss in more detail. He also, unfortunately, people missed out on the other 2 things that he talked about. With the 4 elements, he talked about what can only be described as forces. And he called them love and strife. But if you read Newton's Principia, Newton talks about attraction and repulsion, and it sure sounds like Empedocles was thinking of attraction and repulsion and along the lines of love and strife. He also made some remarkable guesses. He accurately described the mechanism for the senses of smell and taste, which is quite extraordinary, considering he had no access to microscopes or any modern knowledge of physiology, or much of anything. It's remarkable how right he was. So when I say he almost did have superpowers, he certainly had an enormously impressive intuition and amazing intuitive insights. Okay, so this culture, so those are the 2 most cultish of the 2 Greek philosophers, mainstream Greek philosophers. A consequence of this cultish behavior was that ancient Greco-Romans expected philosophers to hold back the most important knowledge for their senior initiates. They'd tell them something like, I can't teach you the most powerful secrets until I've strengthened your brain, right? Your brain would melt if I told you the real secrets. And this was fairly characteristic of cults, right? It still is. I mean, the main purpose of a cult generally is to control people. And so they, they were controlling their followers. Was there a question there? No? Okay. Yeah, they behaved very much like that. The continuing on the cult discussion, Aristotle, who's probably the greatest of all ancient philosophers, and to whom we owe an awful lot of the founding of science, never had a cult. he instead he wrote accessible books without jargon in them. And he published those books where everybody could read them. And according to Cicero, who lived centuries later, these books were very well written. They were brilliantly written. However, during the Roman Empire, I said a century or so, that's wrong. It was later, it was during the Roman Empire. When some notes were found in a basement, and they were about Aristotle's lectures to his students, everybody said, "Oh my God, there's the real stuff. That's what he was hiding from us." And they all wanted to know about it. And they were so obsessed with these point form notes from Aristotle that they forgot all about his books, and the books have all been lost, right? So it's rather as if people in the future were to come back to our own time and try to understand our history by looking at the conversations that anti-vaxxers have, you know, that kind of paranoid view of the world. Oh, the real secrets. Now we're going to find the real secrets. And we lost everything that he was telling publicly to people. But that was because they felt that everybody was greedy, and that the only reason anybody would ever have for publishing something or for divulging reasons was for reasons of power and money. They just didn't believe that Aristotle would give it away. But he did. And in that regard, he is very much, one of the founders of science, because we still think science should be given away. Right? And there are some, there's a view in philosophy of science that it's not really science unless it's published, right? If you do it privately, it's not science. So, so we have that. All right, but there was a difference with Greek holy men, with Greek philosophers. The Greek public took philosophy as a sport. They took it that the philosophers were engaged in some sort of contest, and they wanted to be entertained, so they volunteered to watch this. Well, they paid, in fact. They paid to watch debates between philosophers. Debates were organized as prize fights. Promoters booked arenas and set up prize fights between philosophers, and the public paid to attend. And then the audience voted. At the end of the debate, the audience voted who had won the debate, and the promoter paid a purse to the winner, right? So they were literally prize fights, philosophical prize fights. This preference for sports among Greek audiences led the philosophers to try to look for an argument or forms of argument that could not be refuted. And that's what we call proof. So it's an accident of the cultural context that Greek philosophers decided they needed to find knockout arguments. And so they went searching for knockout arguments. Thales was actually the first. He discovered geometric proof. It's not the modern style of geometric proof. That comes much later, from the 3rd century BC, from a guy named Euclid. Side angle side theorem and all that kind of stuff, right? This is the stuff you learn in school. So that's Euclid. We learned him in school. But the earlier version of geometric proof, I don't have time to lay out an exposition. I originally did, but I took it out because it was too long. But it's just moving things around. And like, you'll agree that if I turn this triangle, it's still the same size, right? And it still has the same area. So now I can put two of these triangles together, and you'll agree that that's twice the area, that sort of thing. That's the kind of argument they had at that time, proof that they had at that time. Anyway, that was invented very early on by Thales. Euclid's book, by the way, wasn't equipped with any explanations in words. Euclid's book was just a selection of drawings. And it wasn't until 700 years later, in the 6th century AD, that a guy named Pappus added verbal descriptions to Euclid's textbook. And Pappus added them because he got himself a copy of the textbook, but he couldn't find a math teacher. to tell him what the diagrams meant. He had to figure them out himself. And so already at that point, the 6th century AD, the general public had lost interest in math so much that you couldn't find a math teacher, even in a big city. Papists couldn't find a math teacher. So that's a shame. But that shows how things had gone in that length of time. Incidentally, some people think that Pappus was wrong about at least one of those diagrams. There's only 2 or 3 experts in the world who carry out that argument. I'm not one of them. I can't even understand a lot of what they're talking about, but they think that the interpretation is wrong and it's not proving anything like what Pappus thought it was. Anyway. Okay. Verbal proof, what we call logic, was discovered in the 4th century BC. Now that was discovered by Aristotle, okay? So before Aristotle, when people argued, when Greek philosophers argued, they didn't say, there, I've proven it's right. They said, isn't that beautiful? Because they thought truth was subjective. They thought truth was just a form of beauty. And so truth is subjective, and therefore you just have to, I have to convince you that this argument is more beautiful than some other argument. Aristotle worked on, let me back up a bit. So Socrates championed the reality of truth, but he also did not ask whether arguments are true, only whether they were beautiful. Okay, so there was, at the same time that Socrates lived, there was a group of philosophers called the Sophists who specialized in the technique of argument. And Socrates was actually trained by a sophist, and he was in fact a sophist. He was not the enemy of the sophists. He was the best of the sophists, right? He won most of his arguments. He lost a few, according to Plato. And we don't have any way of separating what Plato tells us from what really happened. There was a subset of sophists called the skeptics, who held that argument was just bullshit. And you could successfully argue any claim, and then you could argue its inverse and be just as convincing. In fact, there was some, and notably a guy named Pyrrho, the skeptic, who went around doing just that. He'd argue for one side of an argument, and then he'd turn around and argue for the other side. And he sounded convincing both ways, right? And so the implication is that logic is just bullshit, that in fact you can't find the truth from logic, from reasoning, from argument. You can't find the truth. Socrates rejected skepticism. He thought there had to be some actual real truth. And you should be able to find it through argument. So this crisis led to the reform of Greek philosophy, because basically the skeptics were a challenge to everybody else. So Socrates had a famous student named Plato. Probably heard of him. Plato couldn't solve the problem of provable truth, but he started a school, the first real school of philosophy, the first place you could go to study, not just as a cult member, one man's philosophy, but to study the whole history of philosophy and all the different ideas, all different schools. And that school was called the Academy. Now, Plato had a brilliant student at the Academy named Aristotle. I've already talked about him. Aristotle took all the courses he could take at Plato's school, and then he stayed doing research financed by Plato. So in effect, he was doing what we call postdoc research, right? One of his research projects was called the Rhetoric Project. Now, a rhetor in ancient Greek is a speaker, an orator. So the Rhetoric Project is something to do with convincing, probably something to do with convincing speech. But we don't have any more documentation about it, just a passing reference. However, we do know from Aristotle's notes, the ones that survived, that Aristotle taught two courses about language in his school. He taught a course called Prior Analytics, which was about grammar, parts of speech, verb forms, and so on. Okay, grammar was one of the big triumphs of ancient science. Understanding grammar. It was very important because Greek is a terrible language for philosophy. It's extremely ambiguous. Every word has like 6 different meanings in ancient Greek. And so they really had to understand grammar well to figure out anything, even to figure out their own arguments. Anyway, today we'd call that syntax. The second course, posterior analytics, was about the content of sentences. And today we call that semantics. And from his notes, we know that the posterior analytics course was about deductive logic. How can you be sure that an argument is correct? Well, you have to follow a form that is always correct, right? So Aristotelian logic deals in syllogisms, which is a set of 2 propositions and a conclusion resulting from it, right? I don't know, Socrates is a man, men have 2 feet, therefore Socrates has 2 feet. That's actually a false conclusion because not all men have 2 feet. But it shows you 2 propositions and a conclusion that could rationally and logically be drawn from the 2 propositions. So that was the form, that's the only form that Aristotelian logic allowed. But it's flexible enough. I mean, it's tedious compared to modern forms of logic, but it's good enough. It was used right through the Middle Ages. Aristotle had no proof that his logic, his syllogisms actually worked. He just said, well, it looks like these always work. And nobody was able to show counterexamples, so people accepted it. We're still in the same position today with regard to logic. There are logicians, today, there are philosophers who specialize in logic, and they're very skeptical about logic. They're not at all convinced that logic actually works all the time. And of course, there are specific examples of it where it simply doesn't work, like the statement, this statement is false, right? Self-reference explodes logic, destroys it completely. So there are severe limits on logic. But nonetheless, so we can't use logic to prove logic. That's the basic, problem. You can't use logic to prove logic. Too bad. Nobody's ever proven logic works because you can't prove it. There's a question there's an answer that'll never be proven, probably. Probably, unless somebody surprises us with new discoveries in logic. Okay, so before the discovery of proof, knowledge was collected and published in books, which were called wisdom books, right? So the Bible is a wisdom book. The Torah is a wisdom book. The Quran is a wisdom book. So those wisdom books were blessed by tradition as wisdom, right? After the discovery of proofs, philosophers no longer considered that tradition was enough. They were looking for provable arguments. And that's the rootstock of science, right? Provable, hence reliable knowledge. So already by that time, by the 4th century BC, you already had the beginnings of real science, which is trying to find reliable knowledge and not rely just on what people believe traditionally. Okay. Greek philosophers discovered paradox through logic. This seems like it is a digression, but it's another crisis they had. Parmenides, this is early on, so I'm covering it early in the lecture. Parmenides lived in the 5th century BC, so he was in the 2nd or 3rd generation of philosophers. And he argued that change was impossible because change involved something coming into existence that did not previously exist. But in his view, coming into existence is a reflexive verb. That is, for a thing to come into existence, it has to act on itself. You know, I can't brush my hair unless I exist. I can't dress myself unless I exist. So how can I come into existence unless I exist, right? So he classified all change as some sort of coming into existence. And so that led him to the paradox that the world as we know it can't possibly be the way it looks. Everything we see is false. It's all a delusion. And so he dismissed the whole thing and said, the world as we know it is impossible. He said there's just one big white sphere, and that's all there is. And it never changes. It can't change. And that's all there ever will be. Of course, this was crazy. Right? He had a few disciples, notably Zeno, who's famous for his paradoxes. But he didn't have that many. But it presented a problem. It looked like a logical proof that everything we believe has to be false. Eventually, other philosophers found ways around Parmenides, but they had to create an arbitrary rule that said natural philosophy must preserve the appearances. That is to say, it can't deny the way we see the world. It can't just go against the pragmatic experience of the world. And so that's the beginning of the modern distinction between science and mysticism. Namely, that if you're telling the universe that you know better than it does, then you're a mystic and not a scientist, okay? The most historically important example I can think of for that distinction came in 1906. There was a meeting of scientists to discuss special relativity. And the two fathers of special relativity were there, Einstein, of course, and Henri Poincaré, who actually was more the founder of special relativity than Einstein was. And so the two of them were there, and they were defending special relativity. Somebody in the audience asked, but all this stuff that you're talking about, all these paradoxes, like time getting slower when you move fast, and things getting shorter from front to back when they move fast, they all disappear when you rendezvous with that person or that frame that they're in. All that stuff seems to disappear. So surely it's all just optical illusion. And Henri Poincaré was willing to say, who was a much better mathematician than Einstein, but not as good a physicist. Henri Poincaré said, yeah, it's an optical illusion. Einstein said, it's not an optical illusion because it's experienced by every particle in the universe, every proton, every neutron, every electron, and every photon. They all experience those effects of special relativity, like time dilation and all that stuff. So it can't be, we can't view it as an optical illusion. We have to view it as reality. Otherwise, we're mystics, not scientists. So that was an extremely important development, and it established a principle that hasn't been used very much, but is actually very important. What I like to call Einstein's reality principle, that if something is experienced by everything in the universe, then it is real. It's not an illusion, it's real. Okay. That's a footnote on that slide if you were to download the slides.
Gordon, I'm just wondering if you might ask if there's any comment just at this point that relates to what you've said so far. It's really quite interesting sweep of history here.
Yeah, any questions? Any comments?
I don't see any hands up.
Okay. All right. So we're still fairly early on, though. I haven't tied the whole picture together yet. We've got a lot more tying together to do. So paradox led to atomism. This is a weird thing. The existence of atoms was deduced purely by logic. They had no way to view atoms. They had no way to test for the existence of atoms. They didn't know anyway. They just purely by logic deduced that there can't be an infinite number of substances. But at the same time, there's a lot of different stuff out there, stuff must be made out of a smaller number of substances. And how do those substances exist? Well, they must be miniature versions of Parmenides' sphere, because they can't change. They absolutely can't change. So atoms exist and have existed forever. That's the ancient version of it. And they hook together. They must have like hooks and eyes on them so that they can hook together into what we call molecules. So they deduce the existence of atoms and molecules purely by logic, which is extraordinary, I think. Anyway, so the atomists, not all philosophers agreed at first, but over time they gradually came to agree, because there was no other explanation that anybody thought of that made a better sense. Of course, there are more than 4 natural elements. They thought there were only 4: air, earth, fire, and water. That's Empedocles' list of elements. And of course, we know there's more than 4. There's 92 natural elements, and now we got a bunch of synthetic ones as well. And we also know that there are subatomic particles that make up the atoms, but that's a whole different story. It's the same principle, just applied at a deeper level now that we have the limited number of subatomic particles. Okay, this is a part that people don't realize. Ancient philosophers of science did perform experiments when possible. For example, in the 4th century BC, there was the question whether air really exists as a substance, right? When it's not moving, is air a real thing? Strato, the physicist, describes experiments to prove that air exists, even when it's not blowing as wind. His experiments prove that a cup, when it's empty, contains air. And the experiment is simply this. Well, he describes a couple of experiments, but this is the simplest one. You take a cup and you immerse it. Now, they didn't have clear plastic cups, but you can see that when I immerse the cup, the water only comes a small way in. What Strato suggests is that you pull the cup out again, and then you look inside and you can see where the part is that's wet, and most of it's still dry, right? So something kept water from coming into the cup. So there had to be something there. The empty cup can't really be empty. Then Strato suggests drilling a hole in a cup. Well, I did that this morning with my power drill, and it unfortunately cracked the cup. So I can't really do this part of the experiment properly, because I'm supposed to be able to cover the hole with my thumb, but it still leaks even when it's covered. Nevertheless, you can see that when I released my thumb, the water level went up a lot faster. And in fact, now the cup is wet all over on the inside, right? So this is an experiment from circa 287 BC to prove that air actually is a thing, right? It's not just, it's not nothing when it's not wind. So wind isn't the basic substance, air is the basic substance. Okay, he also talks about the bubbles coming up, and you couldn't see that happen too fast, but if I had a less leaky cup with a smaller hole in it, you could see the bubbles come up. And what are the bubbles? You know, where the bubbles come from? There's something. They seem to be something themselves. They're air, right? So that all suggests that air is a thing, and that was taken as proof. The debate came to an end with that argument by the physicist. Acoustics is an area where they did very well indeed. They figured out that sound is vibration of air. The higher pitched sounds vibrate faster. And even that for a given string, the rate of vibration is proportional to the length of the string. What made it possible to do this was that they had a suitable test instrument. You can call it a laboratory instrument, but in fact, it was a musical instrument. The single-stringed monochord. Literally a musical instrument with a calibrated scale on the neck. Now, the original Greek kithara right? You've probably seen pictures of it in artwork. It didn't have any neck on it, and you had to pluck it with the right hand, and you press against the back of the strings with your left hand to make chords. That was a very difficult instrument to play. Around 300 BC, somebody put a neck on the damn thing. And it was still called a kithera, but it was a kithera with a neck. And that made it much easier to do chords, because you could do chords on the neck and just pluck with your right hand. And because, you know, your hand didn't have to move around like this, it was just on a neck where it was easier to, it could position itself by looking for frets and so on and so forth, right? And much easier to control. So that was the invention of the lute family of instruments. By the way, the word kithera for that ancient Greek instrument has come down into English, not through scholars, but through ordinary, everyday people using the word to describe an instrument that they played. And it has entered into the English language, where it's changed form slightly. It's the word guitar, right? The word guitar is the same word as kithera. It's come down directly from generation playing guitars and teaching the next generation to play guitars. Anyway, monochord wasn't a real instrument. The monochord was invented by teachers of kithera playing. Kithera playing was a very important activity in Greece at the time, because Greek society was very segregated between men and women. More so even than Saudi Arabia today. Women could not go out without a male relative to escort them. They couldn't meet any men outside the family, really. The only thing that you could do where both sexes were allowed to attend was musical performances. And since the kithera was such a damn difficult instrument to play, it was a good thing to show off. So they all used to learn to play the kithera as a way to meet somebody, to impress somebody. And so there were a lot of books published about how to play the kithera. And those authors, the authors of those books, explain the principle using a single stringed instrument. So a kithera with a neck and a single string. And that is what the scientists built on. That's what the philosophers built on. They use, and in fact, Claudius Ptolemy, who lived in the 2nd century AD, actually built monochords for use in the laboratory and used them in laboratory experiments. And then he went even further and he built multi-string monochords with up to 8 strings, which of course means they weren't really monochords. But anyway, he built test instruments. And these test instruments, combined with the fact that there is a direct proportionality between pitch, well, it's an inverse proportionality, between pitch and length of the string, made it possible for them to completely deduce all those marvelous things that they deduced about sound, and specifically about music. They, in those days, it wasn't called acoustics, it was called harmonics. And part of it was trying to understand why some notes are sound good together and some sound terrible together. Okay. Ptolemy also performed other experiments. Most famously, he measured the diameter of the Earth by using a surveyed distance and a difference in the angle of sunlight coming into a well in 2 different places, and they had a surveyed distance between them. So he was able to, I don't know if you call it an experiment exactly. Well, it is sort of, whatever. Anyway, he deduced from that the size of the Earth. So acoustics and the work by Ptolemy shows how far they could go if they had a suitable laboratory instrument, right? The biggest problem was lack of suitable instruments. They had no lenses. The Greeks had no lenses. Now, it's possible that the Carthaginians knew about lenses. There's some slight evidence. that maybe they knew about lenses, but the Carthaginians were butchered. They were genocided by a Roman general. And so if so, the secret of the lens was lost. The Greeks certainly didn't know anything about lenses. So they didn't have microscopes or telescopes. And they didn't have thermometers, so they had no way to do thermodynamics. You see, they didn't realize the importance of test equipment that could put numbers on things. That's something that was only realized really in the 1600s and 1700s, when scientists in the modern era, early modern scientists, spent a lot of effort just to get numbers for everything, to measure it. Okay. There was a point I wanted to make in this footnote. Though they didn't have lenses, they had mirrors. They analyzed reflection, and one ancient philosopher, Diocles, 190 to 180 BC, analyzed the behavior of a parabolic mirror, but he didn't analyze it in terms of light, because people were using parabolic mirrors to start fires. And so he said, oh, how does that work? So he analyzed it in terms of particles of fire bouncing off the mirror. And so they missed by that much understanding parabolic mirrors, which of course you can use them in place of lenses, right? You can use them for telescopes, but you can use them for microscopes too. Anyway, so that's a drag, but there you go. That's often the case though, right? In the history of technology and history of science, you often find people who were that close, but they didn't realize what they were close to. So they just ignored it. No follow-up. Too bad. That's the trouble. You don't know where you're going to go, right? I have a saying that I like to lay on my students, that engineering is what you do when you know what you're doing. Science is what you do when you don't know what you're doing. And philosophy is what you do when you don't know whether you're doing anything at all. Anyway, so science began to change Greco-Roman society. Now, this is important because there's a concept that's been promoted mostly by Marxists, I believe, or Marxians, which is people who don't necessarily vote socialist, but they subscribe to Marx's theories of society. They believe in the importance of the means of production. Anyway, a lot of academics are Marxists or Marxians. And so a lot of them tend to believe that religion is always at odds with science. But in fact, it's much more complicated than that. Sometimes religion has been at odds with science and science with religion, but other times religion has benefited from science and taken it up and being promoted by science. There's a good example of that. Well, actually, I'm getting ahead of myself with that example. So let's back up a little bit. I should have read this. Philosophers, to begin with, did not plan to refute traditional beliefs. They thought traditional beliefs were right, generally. But as they went on, they ended up doing so, right? Their criticism and their argument ended up disproving a lot of stuff that was widely believed. By the 3rd century BC, already by the 3rd century BC, philosophy of nature had explained the wind as hot air rising and cold air rushing in to take its place, right? They couldn't necessarily explain why hot air rose, but they understood that hot air did rise, and that happened. Eddies in streams, I gave you that example before. I said eddies are hard to explain because the water is running uphill, at least part of the time. Halfway around it's running uphill. So how is water running uphill? They explain that by saying that there's a tendency for rotational movement to continue. But we call it rotational inertia. So that was their explanation for eddies. And again, by the 3rd century BC, they'd shown that the planets had no free will, so they couldn't be gods. right? Because deities are supposed to be like animals and human beings. They're supposed to have free will, and if they don't have free will, then they're not gods. So by the 1st century BC, there was a tendency to regard the old religion as stupid, as hick religion. And many Romans converted to Judaism. The reason that many Romans converted to Judaism was that the Jewish God was happy to stay in the Holy of Holies in the temple in Jerusalem and not mess about interfering in everything. So that made it easier, right? And it was cheaper and simpler to be a Jewish Jew than it was to be a pagan, because pagans had to go to all these ceremonies. Today you have to wear a yellow flower here, and 2 days later you have to go to a temple and take part in some ceremony or say some chant or some damn thing like that. It was very complicated. But by becoming Jews, they got rid of the requirement to observe all those religious rites, because Jews were only allowed to observe the religious rites concerning the Jewish God. So it got them out of all that nonsense. So that was already happening by the 1st century BC. We have evidence for that. We know, for example, that the Roman Senate was pissed off by Jewish evangelism. And we know, in fact, that the poet Ovid was also pissed off by Jewish evangelism. And we also know from archaeological evidence that at the end of the 1st century AD, around 100 AD, about 1 in 9 residents of the city of Rome was a Jew. There were that many temples, because the temples, Jewish temples, all had they had the same narrow range of sizes, and they always had a certain number of worshipers, so within a 2 to 1 range. So you can just count the temples, and then you know that there were an awful lot of Jews. It was far too many. I mean, we're talking about a city of 1 million people. So 1 in 9 is 110,000 people. They couldn't have had 110,000 migrants from the Middle East. So that confirms that there were, in fact, a lot of conversions to Judaism in those days. Later, Christianity came along and benefited the same way, because it was considered kind of a branch of Judaism, although it was open to non-Jews. There was a big struggle about that in the early church, but never mind that. Anyway, it got people an opportunity to not worship all those pagan gods. And remember, there were hundreds of thousands of them, perhaps millions. So, related to this, by the 1st century AD, there were a lot of temples claiming to show off miracles on a regular basis. And we have a book published at that time by a mechanical engineer or a scientist of mechanics, the two overlap. And he called himself Heron, which is an English hero, of Alexandria. We don't know much about him because his book was debunking religion. And so it was highly illegal in the Roman Empire. They were terrified that there would be war between religious factions, right? They were terrified of war between the cults. So it was totally forbidden to say anything public against anybody else's religion. And that, in fact, is what got Jesus in such trouble, right? I mean, he said that the temple elders in Jerusalem weren't doing a good job. He thought they weren't pious enough. And so he got in terrible trouble for that. He got crucified for it in the end. Anyway, so Hero of Alexandria doesn't tell us anything about himself, so we don't know anything about his personal life. We're not even sure what century the book was published. It's published in a dialect of Greek called Koine Greek, which was an artificial dialect and was used for trade. And in his case, he used it to hide his own natural accent. So we can't even tell what city he came from. And we don't know whether it's 1st century or BC or 1st century AD, which is really too bad, because one of the fake miracles he describes is making a jug that has a partition in the middle, and it has air holes at the top in the neck, and you can cover up an air hole with your thumb and cause it to pour out of the other side without emptying this side, or vice versa. And so the purpose of this trick jug is so that you can put in water and you can pour out wine. And that might sound familiar to you, because that, of course, is what Jesus is alleged to have done at the wedding in Cana, John 2:1-11. So here's a contemporary writer saying, look, this is a trick that holy men do, and it's just bullshit, right? This is how you can arrange it. This is the trick you can do. So it's very interesting. Okay. We have another example of how people had, at least the elite, the Roman elite, had lost all faith in the old religion. Titus was the son of Vespasian. Vespasian was elected emperor. He was actually the first elected emperor. He was elected emperor, and he was in the Middle East when he was elected emperor. He had to go to Rome to take up his position as emperor. His son was with him in the Middle East, so he left his son in charge of the Middle East, right? In charge of Roman forces in the Middle East. And Titus was also the designated heir, right? He was the Caesar, as they called it, designated heir after the emperor. So the Romans were having a lot of trouble with Israeli nationalists. There were two groups of Jews, right? There was the Israelis, and there was the Judeans. And they had quite different political histories, but the Israelis were a big problem for the Romans. The Israelis included fanatical groups, and in fact, we get the word fanatic from a group called the Fanatics, who were so extreme that they swore when they went into battle against the Romans that if they lost the battle, they were going to kill their own wives and children and then themselves. And they lost the battle against the Romans, and they did it. They slaughtered their own wives and children and then killed themselves. That's how crazy they were. There were other less extreme Israeli nationalists as well, but they were a severe problem for the Romans. You know, they just wanted a nice orderly empire, and here these people insisted, no, we won't surrender. So Titus found out that all Israeli nationalists agreed that the Temple of Solomon was essential to the Israeli state, okay? The Temple of Solomon that existed at that time was the second temple. It had been demolished previously, and then one of the Herod, I can't remember which one, but one of the King Herods in that dynasty had rebuilt the temple, not very well apparently. He was just using whatever bits and pieces were lying around. Nonetheless, he rebuilt the temple. And so the temple encouraged Israeli nationalists to believe that they could have a nation state again. So Titus wanted a way to get rid of the temple. So he went, now you have to understand how much impiety was punished, right? If anybody else had tried to do what he did, they would have been crucified, literally. But Titus, well, he was the emperor's son, right? And he was the heir to the empire. So he got away with it. Anyway, what he did was he went to the temple and he talked to the chief priest inside the temple. You can still see what it's like. The Dome of the Rock is currently on that very site. And there's film that shows the interior of it. And there's at the top of the hill, it's built on top of a hill. At the top of the hill, the rock has a kind of horizontal crease in it. And that's where temples were typically built by pagans, because they thought this was a set of vulva belonging to Mother Earth, right? So they usually built temples in that kind of place. And there's no exception. Keep in mind that Judaism was originally an offshoot of paganism. So he went into the temple, and there set up at the top of the hill, there was the Holy of Holies. And Titus talked to the chief priest, and he said, well, you know, what's this about? What's this Holy of Holies thing? And the chief priest said, oh, that's where the Ark of the Covenant is. And it's where our God hangs out. And so Titus said, well, he knew the answer, of course, but he asked the question, what would happen if I looked in? If I opened the curtain and looked in to see the Ark of the Covenant, right? And the temple priest said, the chief priest of the Israelites said, oh, your face had melted and melt. And so Titus said, well, let's put it to the test. And he opened the curtain and he looked in at the Ark of the Covenant, or whatever was there, and his face didn't melt. He didn't even die of a heart attack. Nothing happened. And so he let the curtain go and he said, this temple is a fake, because that's a fake miracle. You promised a miracle and you failed to deliver it. So this temple is a fake. And then he ordered his troops to destroy the second temple. So that's why to this day, there's just a heap of rubble there. The temple of the dome was built later by Muslims on top of the heap of rubble. But the heap of rubble is still there. Anyway, it's an example of how science defeated superstition. And the political consequences are unfortunate, but the essence of it is, yes, we'll put it to the test. Why not? So you have at this point a society in which a lot of people are willing to say all that old stuff is fake, right? Christians went even further. The Jews at that time said, well, our God doesn't allow us to worship other gods, but there are other gods. They accepted the existence of other gods. That's called henotheism. The Greeks, the Christians went even further, at least some of them did, and said there are no other gods. There's just one God. And for that, they were condemned and tortured as atheists. That's how they were killed. They were condemned of atheism and tortured to death, unless they relented. You must remember that about how the martyrs were treated. They were given a chance. If they just relented and said, I renounce Christianity, then they'd be let go. And it's only if they did it a second time, on the repeat offense, after they'd said that they weren't going to do it anymore, that's when they were put to death. Anyway, so, but there was a strong movement to find out how many of these miracles were fake, because there were just so many temples where the priests were making a living, from people coming to view the miracle. It also worked the other way. Sometimes it goes backwards and people throw out the baby with the bathwater. The Hippocratics are a well-known, they're considered almost the epitome of ancient medicine, but they were they wanted to eliminate superstition from medical practice. So they rejected anything that sounded like a reference to animism. So the temple doctors, who based their work, whose work was pragmatic, was based on historical experience, said there are such things, and we see this in Leviticus. I didn't put the quote in. I didn't put the actual reference to the text, sorry. But there is in Leviticus a whole section of medical advice to temple doctors, to priests acting as temple doctors. And one of the things it talks about is defiling disease, which is just another way of saying infectious disease. And that you prevent its spread by isolating the sick and by burning their clothes. So they understood the existence of infectious diseases, whereas the Hippocratics just refused to believe there could be such a thing, because it sounded to them like the description of infection, sounded to them like a description of spirits occupying people. And they didn't like the idea of spirits occupying people because they thought that was animism, right? So they actually fell behind the temple doctors in that respect. I'm going to have to hurry up here. It's already 3 o'clock, coming up on 3 o'clock. Okay. So we have the collapse of the Western Roman Empire in the 5th century AD. But Greco-Roman culture was not lost. It didn't stop. The Eastern Empire, the empire had already split in two. There was a Western Empire and an Eastern Empire just because it was too big. It was geographically too big. You couldn't march from one end to the other in a reasonable length of time. So the empire had already split, and the Eastern Roman Empire did not fall in the 5th century. It continued, right? So, and that's just to confuse things, some historians call the Eastern Roman Empire the Byzantine Empire, but it was really the same empire. And they called themselves Eastern Romans right to the very end. That lasted for another 1,000 years, right, to 1453, before the city of Constantinople fell to Turkish cannon. And it was, and in fact, the western outpost of the Eastern Empire was Venice, which was only built in 500 AD by refugees from Rome. And it lasted for another 300 years or 250 years. Other cities in northern Italy also survived, largely because the warlords who were marching south, they just wanted to hit Rome, right? Rome was the target because they'd heard so much about Rome. So they just marched past the cities in the north. So the cities in the north actually survived and kept their Roman culture. So Greco-Roman culture did not die out. It was heavily threatened and reduced greatly in size and extent, but it did not die out. Okay, in the 11th century, the Catholic Church, which at the time was the only surviving Christian church, there had been a bunch originally, but the once the official Roman Empire Church, once one of them was picked as the official Roman Christian church, it destroyed all the other Christian churches. So the Catholic Church is the inheritor of that. In the 11th century, the church established a school system with parish schools at the bottom, and then a bishop's school at the level of a city, and then universities at the very top. This system is clearly modeled on Plato's Republic. Except that Plato's Republic talks about a republic of philosophers, and instead the church scratched out the word philosopher and wrote in cleric. But it's the same thing. And that's the invention of the modern university. Medieval universities were taught by Dominican friars, it's true, they were part of the Catholic Church, but they did research and they did teaching, and they combined research and teaching just as we expect university professors to do. So it's that's the beginning of the Western university tradition. The 11th century AD, the first three universities were Oxford, Cambridge, and University of Paris, were all established late in the 11th century. There's a major technological change, which is based on science. In the 13th century, Chinese chemists discovered what we now call gunpowder, but it wasn't called gunpowder by them because they used it for fireworks. Less than a century, about 75 or 80 years, that's all. The knowledge reached Europeans. Europeans immediately started using the fireworks in warfare, right? So, and I can hide behind a hole in my castle wall and I can stick a sword out and eat pay. That's what it's for, sticking the enemy. Or I can stick a what we might call a Roman candle in there, and I can shoot fire at the enemy. And isn't that nice to shoot fire at your enemies? It's lovely. So Europeans turned gunpowder into a weapon, but they noticed that sometimes stuff would fly out of the Roman candle. And they said, wait, maybe we could use that. So they invented the pot au feu, which is just a pot filled with gunpowder and with a hole where they can put a cannonball or something, what eventually became a cannonball, something they want to shoot out at the enemy. In other words, they invented the gun. And it took them over a century to perfect it and make it work properly. But once they perfected it, that technology immediately went east, right? I mean, before very long at all, the Mongol Empire was using cannons. When they invaded India, for example, as where they're called Moguls, they brought cannon with them because they had gotten that from the Europeans, you see, that they had fought against, and they'd learned the European technology. So this exchange of knowledge back and forth continued to happen, even at times when you wouldn't think it would happen or could happen. It did continue to happen, all right? So we come to Galileo's life in the, well, he did most of his work in the 17th century. The Renaissance was in full swing by this time, and that was all based on the cities in northern Italy that had retained knowledge. And Galileo himself was a university teacher and therefore a Dominican friar, which is significant because it means that his employer, the church, had the right to tell him, you can't teach us, you can't teach that, right? This is strictly an employer-employee relationship. If they said, don't teach that, he was obliged to not teach it. Internally, the church had a trial to establish whether Copernicus's proposal for geocentrism should be accepted or rejected. This was a peculiar thing. They felt they had to establish the truth, which, of course, they inherited from the ancient Greeks. So they, Galileo defended Copernicus at the trial, but he was because Copernicus had passed away, right? Copernicus only published posthumously. So Galileo defended Copernicus, but he lost the trial. But you've got to understand why he lost the trial. He lost the trial because movement of the sun around, movement of the Earth around the sun would take place, they thought, through a cosmos full of air, right? They didn't think the atmosphere just ended. They thought that the whole cosmos was full of air. And so they reasoned sensibly that if we traveled at thousands of miles an hour through the air, the wind would destroy us all, which of course it would if there was actually wind filling the cosmos. And in fact, this wasn't the first time that discussion had taken place. Heliocentrism had been proposed in pre-Christian antiquity by Aristarchus of Samos, so 3rd century BC, but it had been rejected for the same reason. It contradicted physics, or the physics that was known and accepted at the time. Eventually, Galileo invented a new physics of motion, which allowed for heliocentrism, and the church did permit him to publish that as the book Discourses and Mathematical Demonstrations Relating to Two New Sciences, usually abbreviated in footnote references to two new sciences. And he was allowed to teach it as well. He just couldn't teach it on the university property because he was under house arrest. But I understand he was under house arrest because he insulted the Pope. That was a personal tiff between him and the Pope. The Pope was an old friend of his. He made a rather joking, disparaging remark, which I guess he thought was going to be an inside joke between himself and the Pope. The Pope took it negatively and was very unhappy, and so forced Galileo into house arrest. But it didn't have anything to do with his new physics. So he hadn't even devised his new physics at that point. So it's not like the church was really trying to suppress new physics. It wasn't. Anyway, as I mentioned earlier, this textbook, Two New Sciences, contains references to puzzles that come from medieval tests, like shooting a cannon upward. If you got a cannon in a boat that is sailing in perfectly calm water, and beside the mast you have a cannon that's aligned to shoot up along the mast. Where, if the cannon shoots, where does the cannonball fall? Does it land in the direction of motion forward of the ship? Does it land behind the ship? or does it fall back in the ship or even into the can as well? This is all, these were all medieval questions.
Excuse me, Gordon, just for a sec. If everyone could please put their speaker on mute, that would be much appreciated. Thank you. Go ahead, Gordon.
Okay, so so those puzzles were in fact medieval thinkers had come up with those puzzles. And as you know, if you do science or if you do philosophy, it's often harder to come up with the right questions than it is to come up with the right answers, right? So in fact, there was a tremendous medieval contribution to Galileo's work. All right, so medicine is another science that continued from antiquity to the modern era. I'll just mention that. I'm not an expert on ancient or medieval medicine. You have to be a doctor, really. I mean, we have a lot of medical literature from antiquity, but you can't understand it unless you're a doctor because too much of it is specialized medical knowledge. So without your medical knowledge, you can't read it. But that literature continued right through the Middle Ages. The medical doctors continued being literate, and they continued circulating manuscripts and describing new diseases they discovered and so on. So it never stopped, right? Medical research never stopped. Chemistry is a special case. There were scientists, what I'll call scientists, doing chemistry right through the Middle Ages, but not in universities. In universities, they taught the 4 elements, and they were insistent that that's all you need is 4 elements, and anybody else is full of crap. However, alchemy arrived in Greece about 100 AD. It was already at least a few hundred years old, and probably traces back to practitioners of metallurgy, going back possibly thousands of years earlier. So alchemy arrived in Greece about 100 AD, and alchemists were, they wore 2 hats, right? They were both mystics and practical bench chemists. And it's weird, if you look at an alchemical manuscript, there'll be a section describing all this mystical stuff, blah, 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 blah. And then suddenly there'll be a section that's strictly business. You know, you do this, you take this, you grind up this very fine, and you put that in there, and so on and so forth. And it's all laboratory practice. And then there'll be another rapturous mystical section. But at least they kept them separate. I mean, they understood the difference between the two, and they kept them separate. So the schoolmen, that is the teachers in university, did no experiments whatsoever, but insisted on Empedocles' 4 elements. It's also worthy of note that gold, according to the authorities, the university professors, gold was not an element. See, earth, air, fire, and water, those are the only 4 elements. So gold must be a compound, so you should be able to make it, right? So the alchemists were not stupid. They were going on the best authority available, and they were just trying to take advantage of that knowledge. Luckily for the alchemists, that attracted a lot of funding, and so they were able to keep going during the Middle Ages, even though they were not in the good graces of the church or in the good graces of established science. Finally, in the 18th century, mainstream scientists, including Newton and Lavoisier, combined the practice of alchemy with modern mathematical analysis to create what we now call quantitative chemistry. And I mean, we could just as well call it quantitative alchemistry, but they rebranded it by taking the AL off to get rid of the Arabic notation implication, and also to make it sound like they were good. You know, we academics have always been good chemists, but they weren't. Right during the Middle Ages, they were terrible non-chemists. So this is actually a funny situation because it's a science that had a difficult childhood outside of the medieval scholastic system, but it did survive, and it is the basis, it is the foundations of modern science, of modern chemistry, right? Okay. Some things held back ancient science. There was certain mathematics was missing. Statistics, notably. Statistics are a modern development. They were invented largely by Pascal in the 17th century AD. And what he was doing was trying to answer questions about gambling. So it's gambling math that then led to statistics. It's too bad that the Romans didn't get interested in gambling math because they loved gambling, but they never did. It never occurred to them you could apply mathematics to gambling. But you mustn't overestimate the limitations. Otherwise, one limitation that people think of or they believe in is that somehow Roman numerals held people back because they weren't a place value notation. That's not true at all. In the first place, place value notations aren't some kind of magic mathematics. There's nothing you can't do with Roman numerals that you can't do just as well. There's nothing you can't do with place value notation that you can't also do with Roman numerals. And in fact, Roman numerals are easier to learn. But besides that, Greeks knew all about place value. Greek scientists knew all about place value notation because the records that Greek astronomy was built on, the Greek cosmology, modeling of the movements of the planets, was built on historical records from the Babylonians. And so the Greek scientists went to Babylon and they went to the temples and they read these tablets, which had been recorded, of course, in Babylonian. And the Babylonian number system is a base value system, right? It's a place value system. It uses the value 60. And the reason why we still have angles measured in degrees, minutes, and seconds is that it's a direct crib from the Babylonians. The Greeks couldn't be bothered to translate all the angles into a Greek numeric system, so they translated the individual digits, which represented the numbers from 1 to 59, or 0 to 59, and they used those and called them degrees, minutes, seconds, thirds, and so on. The system continues. Okay, sometimes cultural assumptions have held back science. We're almost at the end. Good. Well, we're getting there. Sometimes cultural assumptions have held back science. An example, which is kind of related to Christianity, perhaps, is that the first zoologist, which is Aristotle. Aristotle was a practicing zoologist. He dissected, he vivisected, he made a lot of field observations. If he was any single type of scientist, he was a zoologist. His father was a surgeon, and so he had the skills, so he dissected and vivisected too. Anyway, Aristotle had no trouble at all assuming that we human beings are just another species of animal, right? We're just an animal with some abilities that other animals don't have, but we lack other abilities that they have. We lack their tusks, and we lack their their talons, and we lack their nice furry hides. But we do other things. Good for us. During the Middle Ages, Europeans generally came to assume that we're inherently different from other species. Now, that's probably a Christian influence, but understand that it's also something that people who raise animals for slaughter tend to also want to believe, because they don't want to feel too much kinship to the animals that they're slaughtering. So this has caused a problem, and is still a problem today. Irene Pepperberg, who, as far as I know, is still alive, has spent her whole career proving that African gray parrots are capable of meaningful conversation, not just mimicry, right? She discovered that she taught African gray parrots a limited vocabulary, about 150 words, which are taken from English. And she taught them a very, very simple stripped down grammar, but it is a grammar. And she recorded every single sentence that they'd ever heard from anybody. And she showed that they were making up sentences that they had never heard. In other words, they were conveying meaning. And that proves that animals are not so damn different from us at all, especially since birds aren't even mammals, right? They're dinosaurs, for God's sake. So apparently it doesn't take that much to have a sense of self and an ability to talk about how you feel, which she did. I mean, she had conversations with her parents about how they felt. Her parents would say, "Oh, I feel lousy because so-and-so is being a poop." Another parrot, they had a fight with another parrot. So there's been a great deal of resistance to that culturally among the scientific community. And it's not a religious resistance. I mean, nobody goes to church anymore who's under 60, or hardly anybody. It's just lack of fluid thinking, right? It's just failure to change your thinking. And that often takes generations. And I could give other examples, but I'm not going to because I'd be ranting and raving. So there we are. That, I think, is the last slide. Yep, that's the last slide. So that's what I had to say. And I'm wide open to questions from anybody who wants to ask any questions or make any comments you want. Disparaging comments included. I'm in a masochistic mood today.
Gordon, thank you very much for this rather fascinating and wide-ranging conversation that you presented to us. We do have some questions and comments, I'm sure. And so I'd like to ask first Prébert to speak to his point. Thank you. And after Prébert will be Walter. Go ahead, Prébert.
Can everybody hear me?
Yes, we can.
Perhaps
Okay.
you could
Gordon, I come from India, so I'd like to add some information to what you said. The first point is about continuity. The founders of Indian, I'm using the word Indian to include both Hindu and Buddhist. The founders of Indian medicine, two characters called Charak and Shashruta, are supposed to go back to the 7th century BC. One is the founder of Ayurveda and the other is the founder of surgery. And from then up to modern India, certainly until British education took over, there's perfect continuity. There was no loss in the tradition. The second point I would make is this issue of universities. It's usually accepted that Plato's Academy is the first example, and then, the school at Alexandria. Now, in India, there are two famous universities, or were. One was at Takshila, which was certainly around at the time of the Emperor Ashoka. That was the 3rd century BC. Whether it was before or after the academy, I couldn't say. But the other university at Nalanda was so famous in the 7th century AD that the Chinese scholar Yuan Chang came to study there. He lived there for 10 years, became a very famous Sanskrit scholar, and went back to China, taking back the holy books of Buddhism. All I'm trying to say to you is that this idea that science started with Galileo must be a particularly Western-centric view. And it's based on, as you yourself said, ignorance of the idea of what Galileo built on.
Oh, yes, absolutely.
By the way, does everybody know here where the word Hindu comes from? Let me give you a very quick explanation, which is usually accepted. As Gordon said, the eastern boundary of the Persian Empire rested on the river Sindhu, which of course is known in English as the Indus, corruption. And the Persians termed the people living on the other side of the Sindhu as Hindus. So that was a geographic term to them more than a religious term. And I believe that's where the term, through various, sort of iterations, has emerged. Because if you go back to the earliest Hindu texts written by what we call rishis, which could be translated either as wise men or holy men, the word Hindu doesn't occur in those texts.
Yeah. All right. Okay, good point. Thank you. I didn't mention Indian medicine because although it was very advanced, it was far more advanced than Western medicine. What was it, around 250 BC, that Indian doctors were doing nose jobs, restoring noses that had been cut off. I mean, actually making a whole new nose and grafting it on.
Gordon, it's claimed that Sashruta, who's supposed to be the father of Indian surgery, knew how to do plastic surgery or brain surgery or stuff like that. I don't know whether it's true or not.
Okay, so anyway, it was very advanced surgery, and there was also quite advanced math in India later on. But that may have been stimulated by some Western influence. But the medicine was certainly an independent invention. It's important to realize that in any society, the size of the society, the extent of the population, if you will, who share a culture, dictates how fast that culture evolves. And so China evolved fast technologically and scientifically because it had because the Chinese Empire united a lot of people, but the Chinese Empire was still split up by a whole bunch of different languages. And mind you, that's true also. India was also split up by different, and by different political factions. However, there is, one would expect a faster evolution of science and technology in a larger population base. And it's a point people don't quite realize about our current situation. Today, because globalism has brought together 8 billion people into a single technological and scientific culture, the rate of advancement is multiplying immensely. And so we're getting swamped by such fast technological and scientific change. But on the other hand, we can use the fast technological change to get us out of the hole we're in with global warming. So we need that, and we need to make fast change to get out of all the poisons that we've released and so on. So, but I don't think people realize that. They don't realize that it's inevitably going to be the case that this will progress much faster, that science and technology will progress much faster. I don't remember the number offhand, but Peter McKinnon knows it, that the Chinese have, what, 7 times as many scientists and engineers as the United States does. They've only got 4 times the population. But already that means that most of the technological innovation and quite a bit of the scientific innovation is coming from China nowadays. But it's worldwide, I mean, as countries industrialize, they join in. And I read about solar technology, and there's occasional research articles coming out of Africa. It's all over the world, and that means that the whole rate of advancement is much faster. And so one would expect an antiquity of India, because of its large amount of trade, and even though it was divided by languages and religions and such, that nonetheless it had a good basis for advancing rapidly. And similarly with China, and it did. We know a lot of the technology came out of China. Europe was the backwoods for a very long time, really until the age of exploration. Before that, Europe was the backwater.
I'd just like to thank you for that response as well, Gordon. Graham Creedy has an announcement to make. He flagged me early on, and he has to go shortly. So, Walter, if you don't mind, I'll just pass the floor to Graham to make his announcement. You'll probably post something to our chat line as well. So, Graham, go ahead, and then back to you, Walter. Hold on.
Thanks, Peter. Can you hear me now?
Yes, you're clear.
Yeah, it was about a presentation by Chris Hobbs, whose name came up several times during Peter Chapman's recent presentation to the Foresight Group. And I'd mentioned that Chris Hobbs was going to be giving a presentation shortly. And in fact, it's at noon on Wednesday, and it's to the Canada System Safety Society. And it's on the latest thinking in safety case arguments. You can download the info from the Canada System Safety website. If you search Canada System Safety, you'll get to it. But I'll try to post something in the chat right now. Thanks, Gord. Apologies for interruption, but I really have to go in just a moment or two. Thank you.
Thank you, Graham. Okay, Walter, the floor is yours. And after Walter, Guy Stanley.
Thank you. I really enjoyed the lecture. I unfortunately missed the middle part of it because of some technical internet issues here at the hospital, but I did catch the back end. A question that always fascinated me historically was science discovery basically a point geographic isolated circumstance where the same discoveries were made in different parts of the world, either simultaneously or not, or were they transferred by nomads or tribes or cultures moving from one location to the other? There's a archaeological monolith that was discovered about 200 years ago, just north of the Black Sea on the Sea of Azov, which is called Stone Library or Stone Grave. It's actually not a grave, it's basically a temple like Stonehenge, but it has all kinds of prehistorical pictoglyphs and other writings that's been carbon dated back to 22,000 BC. So this is like pre-Mesopotamia, pre-Babylon, pre-Sumerian, pre-everything. And I've always found it fascinating whether this is like a collection, like is this an earlier version of the famous library, or is this a meeting place where people would come and find information, or is this a place where they would share information?
Very good question.
Okay, I can't possibly speculate about that particular place. Am I being heard?
Yes,
Yep.
you are.
Yeah, okay. I can't possibly speculate about that particular place. There's it used to be thought we understood the evolution of writing, and it happened about 3700 BC, roughly, in Babylonia. But there's some indication that some of the earlier cave drawings and such have structures in them that relate to language. So they may actually be there might be some writing there. This thing you're talking about, I've never heard of. But certainly before the Greeks got involved, in the era of wisdom books, those certainly accumulated wisdom from different places, including mathematical wisdom books. There were mathematical books that listed formulas that were known to work. So for example, the Pythagorean Formula, the square on a hypotenuse is equal to the sum of the squares on the other two sides of a right triangle. That formula was known more than 1,000 years before Pythagoras. In other words, it was discovered by trial and error or whatever. It was pragmatically discovered. We also have an example of one formula, which I don't know offhand, but it has something to do with chords across a circle, and it's in the Babylonian literature, and it's also in the Indian literature, and it's also in other literature. And this one's quite significant because it's wrong. So that suggests that yes, indeed, wisdom was being exchanged over great distances. So that's the best answer I can give you. Once the Greeks got involved, shortly after philosophy took off, the Greeks converted from a non-literate culture to a literate culture. They were already literate to some extent when philosophy started, but they became more and more literate over the next few centuries. And so then people began reading the original words of a philosopher, and you get something more like our current day philosophy, which is spread as the written word.
Thank you. I'll post a link to that if anybody's interested.
Yeah, please.
Okay, thank you. Guy, Stanley, and Preber, and Walter, you can lower your hands. Go ahead,
Well,
Guy.
thanks a lot, Jason. Here. Yeah, very interesting presentation. Learned a lot. One of the distinctions that I remember acquiring years ago was about the distinction between theoretical science and technological development. And I was led to accept a somewhat Western-centric view on theoretical science. But it's really an argument about the structuring of the so-called scientific mind, which in the West is a huge theme. And we're still working with it. We had a presentation a week or so ago on problems of governance that seem to be associated with it. And I just wondered if you have any views on that. You sort of touched on it, but you didn't really develop it. But is that a marker for, as opposed to simply being good with building machinery? I mean, the Brits used to boast that they were not so great engineers, perhaps, as the Americans, but they're better theoreticians. And other people have noticed that most of modern American science, the foundations anyway, were laid by European emigres fleeing the Nazis. So is there something to this distinction? And is it randomly distributed, or is there some cultural development stuff associated with it?
Yes.
What's your take on it?
Hello,
Hello?
Yeah.
sorry.
Yeah, go ahead, Gordon, to answer.
Okay, I'm not sure what the question is.
Okay, the question is there something distinctive about the Western approach to science that you might say the structure of the development of the so-called scientific attitude, which is holding all knowledge as hypothetical and all proofs as temporary?
Okay. Well, I've towards the end, I gave an example of how people still fail to do that, and even scientists fail to do that. It's an ideal of scientific thought.
Yes.
It's also only fairly recently articulated. The debate in philosophy of science has been going on now for about 2 centuries, which by philosophy standards is quite recent. And it hasn't really, progressed very far yet. Philosophy typically takes 1,000 years to get anything sorted out. So, well, hundreds of years anyway. So philosophy of science certainly hasn't sorted that out. I gave my definition earlier, which is my personal favorite definition because it's just mine. And I don't claim that it would stand up to philosophical scrutiny, but I think it's there's just a practical distinction of what you're trying to do, what your relationship is to the subject under discussion. If you're an engineer, then you know the answers, or there are answers that are known. You can look them up. If you're a scientist, you're looking for answers that they aren't known yet. So you don't know what you're doing, but you're looking for answers. And if you're a philosopher, you don't even know if you're looking for questions because you don't know if your question is even meaningful. Honestly, I think that's probably the best approach to them. I don't think that holding all answers to be temporarily or hypothetical is necessarily untrue for any field. Look at Elon Musk reinventing rockets, and suddenly all the old truths about rocket engineering turn out to be false because you invent new truths. And the same thing happens in other areas like the arts. You know, when you invent cubism or you invent impressionism, you're inventing a new way of looking at your craft. So I don't think that it's wrong to say that all that stuff is temporary, and all knowledge, you know, all knowledge is temporary and provisional. So there you go. It shows my philosophical training. I'm broadening it to include not just science, but every damn thing there is. And so I don't think that there's anything special about science in that regard. Not really.
Thank you, Gordon. Walter, did you have anything else you wanted to add beyond the story about the Stone Library? I don't see Walter responding there. Anyone else have a question or a comment? We're at our typical retiring time, but we can continue if you're interested.
Sorry,
Gordon, perhaps you might turn off the recording now.
I posted a link in the chat for anybody interested in Stone Library.
Yes, thank you. I see that too. Any other questions or comments? You can raise your hand or put something in the chat. I don't see any responses. So perhaps we could draw this to a close. I'd like to thank Gordon for a very informative